Crash Course Instrumentation, Episode 38, Ohm's Law in the Lab, Metric Units and Calculations. In this final episode of our Ohm's Law and Joule's Law series, we're going back to the lab to put everything together, formulas, units, and real-world math. What you'll learn: how to calculate voltage, current, or resistance from any two known values, how to use proper metric prefixes, milli, kilo, mega, how to check your answers using units and logic. Refresher: Ohm's law, volts equals intensity, X, resistance or E equals IXR, voltage, V equals current, I, X resistance, R. We can rearrange this equation to solve for any unknown. Intensity equals volts, resistance. Resistance equals volts, intensity. Working with metric prefixes. Instrumentation texts deal with a wide range of values. 4 to 20 milliamp equals 0.004 to 0.020 amps, intensity. 10 kilo-ohms, Joule equals 10,000 ohms. 2.2 megohms, or equals 2,200,000 ohms. Always convert units to base form. Amps, I, volts, E, resistance, O, before calculating. Example 1. Current from voltage and resistance. A 12-volt battery is connected to a 1.5 kilo-ohm IO resistor. Convert 1.5 kilo-ohms, R equal 1500 ohms, dot intensity equals volts, resistance equals 12. 1500 equals 0.008 amps or 8 milliamps. Example 2. Resistance from voltage and current. A sensor draws 20 milliamps at 5 volts. Convert. 20 milliamps equals 0.020 amps. Resistance equals volts. Intensity equals 5. 0.020 x 250 ohms. Do. Example 3. Voltage from current and resistance. If a 500 ohm ORTD has 8 milliamps flowing through it, volts equals intensity x resistance equals 0.008 x 500 tells equals 4 volts. Why this matters in instrumentation. You'll calculate loop resistance when sizing power supplies. You'll verify sensor output behavior under load. You'll troubleshoot weird voltage drops across long cable runs. Sanity check your answers. Amps are smaller than milliamps? Red flag, 24-volt loop with 10,000 ohms. Check your math. Don't guess, calculate. Pro tip, use a formula triangle. Draw a triangle and place V on top, I and R on the bottom corners. Cover what you need to find, and the math reveals itself. Historical insight. Although Georg Ohm published his law in 1827, it took several decades for it to be accepted and incorporated into mainstream education. The first widely used electrical engineering textbooks began appearing in the late 1800s, especially in German and British technical schools. One of the earliest American textbooks to include Ohm's law was written by Edwin and Elihu Thomson, who were early pioneers in industrial electricity and education. By the 1890s, trade schools and polytechnic institutes across Europe and North America were routinely teaching VEIR as a foundational concept. By the early 20th century, institutions like MIT and Cornell began integrating electrical engineering into formal academic degrees, with Ohm's law at the core. Today, it's taught in high schools, trade apprenticeships, military technical programs, and universities around the world. Congratulations! You've now mastered the basics of Ohm's law and Joule's law, the foundation of nearly every electrical and electronic system in industry, thanks to Tony Kuphaldt and the open-source Socratic Electronics project for the models behind this series. Like, share, and subscribe to power up your knowledge with Crash Course Instrumentation.